Hello there, Algebras. Welcome to your Chapter 4, Lesson 7 notes. We are going to analyze some piecewise word problems. So basically what we've done already is we've graphed piecewise functions. So we've graphed different pieces of different functions based on the domain given. So, if I have a linear function and it's only over a specific domain like -3 to 0, I only graph that line from -3 to 0, and then I pick up with whatever function covers this next domain that I was given. Okay. And that was the specific graphing this function over this domain. But that's not the only way we might consider something a piecewise function. Another way we might consider that would be when we're looking at scenarios where, if we're talking about time and distance changing, we might be looking at, oh, okay, we are walking for a certain amount of paces at this time through this time, and then I stopped. Time still passes, but my distance is not changing. And so, what would change there, what would be that piece, is different slopes of lines all taking care of that idea, right? So, all covering that idea in different pieces of my journey. All right. Or one of the ones we look at a lot is like snow falling over time and how the storm changes. Okay. And what that ends up looking like on a graph. And that's pieces of different time periods being shown. So those are just some ideas of how we might look at piecewise functions based on some word problems, based on some stories that we're interpreting. So here, I'm going to start talking about just walking away from home. Not zooming in. There we go. Walking away from home, walking toward home, and standing still. And as time passes, because time is an independent variable, meaning it's going to happen regardless of what else I'm doing or the story is doing. So time is my independent variable. It's my x-axis. Okay. So what does, if y is my distance from home, what does it look like to be walking away from home? Okay. Well, that would be an as time passes, my distance from home increases. So that's a positive slope, right? If we're talking about walking toward home, so if I've been away from home and I'm going towards it, that would look like a negative slope. Time is passing, but I'm getting closer and closer and closer to home, home being 0, right? Because that's my distance from home, right? Standing still. Let's say I'm away from home already, but I'm not moving towards it and I'm not moving away from it. I'm just standing there. That would be like a 0 slope. Time is still passing. That's my x, but I'm not changing my distance from home. So we consider what the x and y variables are representing in our pieces that we create. Okay, so that's part of what you have to be careful of and be considerate of when you're looking at piecewise functions based on some word problems. Okay. All right. What we're going to do is we're going to read 2 stories and we're going to match the accurate graph. Okay, so what I want you to do is I want you to pause it right here, read about Bob, read about Sarah, and see if you can pick which one of these is Bob and which one of these is Sarah. Okay, so pause it here, read them yourself, then turn it back on to see the answer. You paused it, right? Hope so. So Bob is training for a 5K. He starts from his home and jogs for 5 minutes to warm up. Bob then runs for 30 minutes before stopping in a park to rest and drink some water. Then he runs home to finish his training. Sarah spent the night at her friend's house, is going to ride her bike back to her house, and after a few minutes of riding, she realizes she left her phone at her friend's house. She realizes that she is going to miss her favorite Sunday morning show. At this point, she doubles her speed. Okay. Unfortunately, her bike chain slips off. Boy, Sarah's got a journey, huh? Her bike chain slips off and she has to stop and fix her bike. Then she rides her bike the remainder of the way home. Well, the way I would think of this is all the choppiness in these journeys that would be different pieces, right? So let's just consider Bob first, right? He starts from his home and jogs 5 minutes to warm up, then runs for 30 minutes, stops in a park. So there's the jog, here's the run, there's a stop, and then runs home. So 1, 2, 3, 4 different journeys, right? Whereas Sarah started at a friend's house, starts biking home, realizes she left her phone there, goes back. So 2 journeys. Then starts biking fast. There's her 3rd journey, right? Because she doesn't want to miss her favorite Sunday morning show, obviously. Then her bike chain slips off, so she doesn't change her distance to home here, and then bikes the remainder of the way home. So here is Sarah, and here is Bob. Okay. Part of what I looked at was how many pieces in their story, how many chopping pieces in their story occurred. Sarah had 5, Bob had 4. But the other thing I looked for was, where did Bob start from and where did Sarah start from? Bob started from home. Bob started from home. This is starting home at the beginning, 0 time passing. Sarah started at a friend's house. This is starting up here without time passing. Okay, so she's not starting at home. She's starting up here and then heading home. And so that's one of the things that you can look at too. Both of them end up at their home by the end, but that's one of the things that we can look at when we're trying to match up which piecewise function goes with which story. All right, continuing. Former Regents question alert. I can tell by the font on the picture there that that's a former Regents exam question. So exercise 3, former Regents question. The graph below represents a jogger's speed during her 30-minute jog around her neighborhood. So this is speed, right? This is speed. So be careful with that. This is not distance from home. So that means this is not her standing still. Okay? This is not her standing still. All these are not standing still. They are a constant speed because Y is speed. So that's where the whole watching what the X and Y axes represent is very important. Okay? So describe what happens. Describe what happens between each of these intervals. So I just kind of gave you a big hint, right? And we got to watch the speed. So this is an increasing slope between 0 and 2 minutes. So what's happening? She's increasing speed, right? It's an increasing slope. What's the y-axis? Speed. Okay, 2 to 5 minutes. So 2 to 5 is here. Oh, I just got done saying this is not her standing still. This is a constant speed or maintaining speed, right? This is a maintaining of the speed, keeping it level. That's why we're not changing. We're not increasing the speed. We're not decreasing the speed here. 12 to 14 is here to here. Okay, decreasing speed. See, it's a decreasing slope, decreasing speed there. And again, this is all based on what my y-axis is representing in this case. And then 19 to 20, that's still decreasing speed. That's just a rapidly decreasing speed. It's decreasing, but it's just far more rapid than all of the other decreases in speed have been, right? Looks like some interval training for this jogger. That was really just an interpretation. At the Regents exam, they did ask specifically which interval, which time interval, and they gave you these 4, was this jogger maintaining a constant speed. So, 2 to 5 minutes was the correct multiple choice. We turned that into just looking at what each of these intervals actually are doing. So you could have answered the multiple choice. All right. Exercise 4 is where we really get into it. We're going to read this scenario and we're going to actually graph it ourselves. So we're going to label the x-axis, we're going to label the y-axis, we're going to put each piece on there, and we're going to make it So when we scale the X and the Y axis, we're going to make those scales for ourselves so we can fit all of the scenario on there. Okay. So what I'm going to do is I'm going to read and I'm going to kind of make my own little chart to start out. And then my chart will help me in how I scale, and my chart will help me in how I label. All right. So Paul walked from his house at a constant rate of speed, for 5 blocks in 10 minutes. So this is kind of backwards. 10 minutes, he went 5 blocks, right? And minutes is your X when it comes to this. Okay. So let me just kind of do this. Because remember, this is our time, and that's our independent variable. Y is going to be our speed, right? You know what? Let's do it in blocks. Let's do Y in blocks because it seems like everything that Paul is doing is based on blocks, right? So 5 blocks in 10 minutes, right? So this is going to be our time in minutes. This is going to be our blocks. And that will cover, so it'll be distance. Okay. So this will be minutes for time. That'll help out a little bit. So Paul walked from his house at a constant rate of speed of 5 blocks in 10 minutes. He saw a friend sitting on a bench and stopped to talk for 2 minutes. After talking with his friend, Paul walked for another half block for 1 minute at the same rate. Then he realized that he had left his notebook on the bench and walked back at the same rate to retrieve it. Then he continued walking at the same rate of speed for 8 minutes, another 4 blocks until he reached the school. Okay. So Paul is heading from home to school. That's what we've learned in the scenario. He walks in blocks and minutes. That's his time measurement and distance measurement. So that's what we're going to compare. Let's do some totals, and then that way we can figure out the scale that's going to need to fit on our X and Y axis. Okay. So I'm going to start with 0, 0. And the reason I start with 0, 0 is 0 time has passed and 0 blocks have been walked at 0, 0. So that is like going to be my origin, right? Because I'm only going to be positive time and positive blocks. Not going to be able to go backwards time-wise and backwards block-wise, right? No backwards distance. So at 0, 0, that's when Paul begins, and he walks from his house at a rate of 5 blocks in 10 minutes. So 10 over here and 5 over here is what we're looking at. Okay, it's 10 time, 5 distance. There we go. I just added distance to my blocks there. Okay. After talking, he saw a friend sitting on a bench and stopped to talk for 2 minutes. Okay. So I've already got 10 minutes have passed. I'm adding 2 minutes to that. What's 10 plus 2? 12. And did my blocks change? No, because he sat. So we're still at 5. So notice I'm doing some adding as I'm going. After talking with his friend, Paul walked for another half block. So half, so we get to 12 and a half. For 1 minute. Oh, half block, sorry, we get to 5 and a half, my bad. I was trying to add my X, but it was really my Y that needed blocks. There we go. So we got to 5 and a half blocks, but it was 1 minute of time. So that was 13 minutes that have passed. Goes back, right? We got to 5 and a half, but we have to go back a block, back half a block to retrieve. So he goes back for his notebook. That's 1 minute. He got here. Goes back. That would have taken him 1 minute and half a block down. So we're still at 5 and a half blocks at this point, but back down to 5, right? That was our total we got into. We're back down to block 5. Then he realized that he left his notebook on the went back to retrieve it. That's this. Now, he continued walking at the same rate of speed for 8 minutes, another 4 blocks. Okay. So add 4 plus 5, we get 9 total blocks from Paul's house to the school. How long did it take? Okay, we got 8 minutes added to our total right now of 14. So 8 plus 14 is 22 total minutes that it took Paul to walk to school because of that little bump in the road there. The 2 minute bump in the road. It should have taken him 20 minutes to walk these 9 blocks. Okay, which seems a little lengthy, but okay, we'll give it to him. Right? Now, what that gives me is my totals. Okay, this gives me my totals. So let's count our hash marks on our X for time. Darn it, just under. So I'm not going to be able to go by ones. I'm going to have to go by twos. Okay, I have to go by twos here. So this is 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. What a bummer. So this is time in minutes. All right, that's what's going on here. Now, let's consider up here we have to get 9 total blocks in, even though he walked 10 blocks, and I'll show you that in a second. He did technically walk over a period of 10, over a distance of 10 blocks, but it's 9 total from home to school. Okay, because this was where home was, and this is where school is. And I'll show you how I know based on the story that he actually walked 10 blocks as I put the story up. So let's get our scale up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I can actually go by twos here. Skip, I should have said. I can actually skip as I go up, right? So I can save myself a little bit of room, which is good because I'm going to have to put a half block in there. So that's perfect. That ends up working out pretty well. All right, so home, excuse me, totally forgot to label, distance in blocks. All righty, so we start with 0, 0. Then we get up to 10, 5. So that's what I can use this for, see? As I was going, I'm having time pass, right? Doesn't move. So that's his doesn't move, sits on a bench with the friend. Then we go to 13, half a block. So this is 5.5 right here. And it's halfway between 12 and 14. Then he has to go back to get his notebook. Then it's from 14, he goes to 22 and 9 because it's 9 total blocks from the school. But see, this half plus half is a whole block. That's why 9 plus 1 is 10 total blocks that he walked because he started and had to stop. So the reason that I did the table and kind of took my notes the way that I did was so that when I do this, I can actually just be plotting points to get all my little pieces of Paul's story on here. And of course, the last thing I'm going to do is label this. Now, notice I used a straight edge. And as you guys know, since in this unit, that's like all I focus on is make sure you draw your lines with a straight edge. Make sure you draw your lines with a straight edge. I used a ruler that I always have at my desk, but you know, you could use the side of a thick binder, the side of a pad of paper, the side of an index card, the side of a cardstock piece of paper. These are all ideas of things to use for a straight edge to draw if you don't have a ruler at home, right? Some of you I've actually handed rulers to and said, I don't want it back because they're the little ones, but still, they're good. They're good pocket rulers, right? So now I'm going to label that this is Paul's epic journey to school. Because obviously this was just an epic journey. Almost lost his notebook. There we go. You guys will be able to do this. I swear you will. Here's a great one, and I can tell by the picture that this is a former Regents question. Nice, and I remember this so specifically. One spring day, Elroy noted the time of the day and the temperature in degrees Fahrenheit. His findings are stated below. So Elroy is a budding meteorologist, and he wanted to write out, okay, let's see what Elroy did here. At 6 a.m., the temperature was 50 degrees Fahrenheit. For the next 4 hours, the temperature rose 3 degrees per hour. The next 6 hours, it rose 2 degrees per hour. The temperature then stayed steady until 6 p.m. For the next 2 hours, the temperature dropped 1 degree Fahrenheit per hour, and the temperature was 56 degrees Fahrenheit at midnight. Elroy, what a great meteorologist you just became. All right, on the set of axes below, graph Elroy's data, and look at this. They gave you a labeled graph, right? They scaled this, they labeled it, they're telling you what to do. They even put their own break in here so you don't have to worry about it. So they're not starting you at 0, 0 for temperature and time. They're starting you when they want to at the 6 a.m. mark and 50 degrees. So see, they did that for you on purpose, which was really nice of them. Okay, nice of the Regents exam to do that. All right, so here's what we're going to do. We're going to do the same kind of thing we just did for Paul's epic journey for Elroy's budding meteorology experiment. And we're going to do an X, which is the time of day, and Y, which is our temperature, right? So time and temp. So that's what we're going to do. Okay, so let's reread again. At 6 a.m., the temperature was 50 degrees Fahrenheit. So this is going to be 6 a.m. 50 degrees Fahrenheit. We'll just be really thorough and label, right? Notice that's how they have this. So you know what? I'm going to do 7, 8, 9, 10, 11. This will help us. 12 noon, then 1, 2, 3, 4, 5, 6 p.m., then 7, 8, 9, 10, 11, 12 midnight, 12 a.m. Right, there we are. Here's where I was in the story. For the next 4 hours, okay, before I even read the next part, 6 a.m. plus 4 hours gets me to what time? 10 a.m. The temperature rose 2 degrees per hour. Oh, excuse me. The temperature rose 3 degrees per hour. I was trying to read the wrong thing. Let me just scooch this down again. I'm not graphing yet, so we can still see this. So for the next 4 hours to 10 a.m., the temperature rose 3 degrees per hour. Okay, so 4 hours times 3 degrees per hour. 4 times 3 is 12 degrees we increased. So what's 50 degrees Fahrenheit plus 12 more degrees Fahrenheit? At 10 a.m., we're at 62 degrees Fahrenheit. See how I did that? 4 hours increase, 12 degrees Fahrenheit increase. For the next 6 hours, ooh, that's going to be interesting. We'll count that out in a sec. It rose 2 degrees per hour. So because the way we do time in the 12 clock, right? We can't just say 10 plus 6 is 16 a.m. because that's not how we talk. So what you can think of is, and this gives you, and this is why I put this in here, kind of a clue, count from 10 to 6 and we'll know where we are PM wise, right? So 1, 2, 3, 4, 5, 6 hours have passed. Where am I? 4 p.m. So now that gives me my time to put as my coordinate. Now we need 2 degrees per hour. So 2 times 6 is 12 again. Now we add another 12 degrees to 62 degrees Fahrenheit, and we get 74 degrees Fahrenheit. Okay, so another 12 got added there over more time, though. The temperature then stayed steady until 6 p.m. So 4 p.m. to 6 p.m., there's no temperature change is what they're telling us. So 74 degrees Fahrenheit is where it's at. For the next 2 hours, the temperature dropped 1 degree Fahrenheit per hour. Okay, 2 hours from 6 p.m. is 8 p.m. 2 times 1 is 2. So 2 degrees dropped. We're down to 72 degrees Fahrenheit at 8 p.m. This must be summer. Oh, we said spring. Okay. That's fine. Then the temperature was 56 degrees at midnight. So they're not giving us a time to add to this. They're actually giving us 12 a.m. And they're actually giving us the time to get to, which is 56 degrees Fahrenheit. So these are the points that I'm going to plot. So that's the reason I did it the way I did, so that I can plot these points, and I base that on the scale and the labeling that the regions had given me. So I did it that way. So 6 a.m., 50 degrees. Now, we need to get to 10 a.m. and 62 degrees. Oh, shoot. Let's find this scale in between. 1, 2, 3, 4. Oh, 52, 54, 56, 58, 60. So this is 62 right here. So 10 a.m., 62 degrees Fahrenheit. Now we need to get to 4 p.m. and 74 degrees. So here's 70, 72, 74. 4 p.m., 74. 8 p.m. down to 72. So here's 72. 8 p.m. right here. 72 right here. Oh, what did I miss? 6 p.m. we stay at 74. Phew. Good thing I didn't miss that. Getting my points up there. And then 12 a.m., so midnight, 56 degrees. So 52, 54, 56 right here. And 12 midnight. There we are. And now we'll just connect with a straight edge. We don't have to connect back down to the x-axis or the y-axis. Just connect the pieces that you created just now. So just connect those pieces you created with your straight edge, just like this. Labels are done. You're okay. There we are. Okay. State the entire interval for which the temperature was increasing. So we can see very clearly where the positive slopes are. From 6 a.m. until 4 p.m., we had temperature increases. So I'm just going to zoom out so you can still see my graph. But the answer here, state the entire interval for which the temperature was increasing. They mean the X's. So from 6 a.m. to 4 p.m. was the temperature increase. Determine the average rate of change in degrees per hour from 6 p.m. to midnight. So this is going to be 6 p.m. to midnight. We're just going to use those X and Y values for average rate of change here. So average rate of change, of course, being ARC, F of B minus F of A divided by B minus A. We just learned that a couple days ago. We've just got to state our A, our B, our F of A, our F of B, so we know what to plug in where, okay? So we're saying from 6 p.m. to midnight. So this is your A, here's your B. Your F of A is 74, your F of B is 56. That's what we're going to plug in. So 56 minus 74 over 12 a.m., so we'll just do 12, minus 6 p.m. Okay? Now we'll subtract, again, graphing calculator over here, so just to kind of show you. 56 minus 74 gives me my top number. And 12 minus 6 gives me my bottom number. And since negative 18 can be evenly divided by positive 6, we get my average rate of change of negative 3. So average rate of change in degrees is negative 3 degrees Fahrenheit. And we say negative because we're decreasing 3 degrees Fahrenheit per 1 hour. Hour being the bottom. Let's do that. There you go. All righty. Guys, you can handle this. You can do this. Take your time. Use a straight edge when you have to make your piecewise word problems. Draw that table out. So sketch it out first. Consider the X, consider the Y, consider what you're creating, consider what you're looking at. You got this though. Just consider what your X and your Y are representing when you're doing it. Okay. Pause and think about those things as we went through too. Okay. How these stories match up. That will help you create these stories on a graph yourself later. All righty, guys. This is the end of our piecewise pieces. So, absolute value tomorrow. And we are done with chapter 4. After that, we'll be reviewing and testing. All right. I shall be seeing you or hearing from you. If there's a problem, let me know. I'll talk to you soon. Bye, guys.